Hello everyone, this is part 2 video on past year NEET questions from the chapter Thermodynamics in Physics. Now those who are looking at this video can also take a look at the part 1 so that you will have continuity of questions. We will start with the question that has come in NEET paper 1 of 2016. This is a question based on the refrigerator. So refrigerator works between 4 and 30 degrees. It is required to remove 600 calories of heat every second in order to keep the temperature of the refrigerated space. Refrigerated space means what? This is the low temperature region. So in order to maintain that refrigerated space to be at that constant temperature, it has to remove 600 calories of heat for every 1 second. They're asking us to find what is the power required for operating this particular refrigerator. So if we look at the working of a refrigerator, right, it will be just reverse to that of the heat engine. So how does the refrigerator work? It will derive heat from the low temperature reservoir, which is the refrigerator space. And for doing it, there has to be some electrical work done, that is W. The total heat rejected to the outside surroundings will be what? So this is the high temperature. So surrounding will be at high temperature. Here it is given as what? 30 degrees. And low temperature reservoir is 4. So if we look at the heat engine, right, we'll have the ideal heat engine, which is the Carnot's engine. So in that we'll have a relation between Q2 and Q1, that is Q2 by Q1 will be equal to T2 by T1. Now here also we are going to assume that this is an ideal refrigerator, which will be exactly reverse to that of the ideal heat engine, which means here also we'll have what? In case of the ideal refrigerator, we will have the same relation, that is the Q2 by Q1 ratio will be equal to what? T2 by T1, but we have to keep in mind that both these temperatures will be on the Kelvin scale. Okay, so here let us look at what is it that we need to find. So they have given us the Q2 value. So Q2 value is what? 600 calories in every 1 second. And using the given information, they are asking us to find what is the power required. So power required means what? We're talking about the electrical power required. So electrical power required means we have to find in 1 second what is the W value that is basically needed to operate this refrigerator. Means what? Because if we calculate what is the electrical work to be done in 1 second, that is basically what is the power of the refrigerator. Okay, so how do we find this particular W in 1 second? See here, if you check the options, right, they are giving all the options in watt, which means they are giving the values in the SI system. So first what we'll do is we will take the Q2 value in the SI system. How do we do it? Using the conversion factor. They are clearly giving that use 1 calorie is equal to what? 4.2 joules. Means Q2 in terms of joules will be equal to what? 600 into 4.2. This is we have to keep in mind in 1 second. So for this, what is the corresponding W is what we need to find. That will give us the answer, which is the electrical power required to operate the refrigerator. Okay, now what we need to do, we need to look at the relation between the Q2 and Q1 values with the temperature, assuming that this is an ideal refrigerator. Okay, they are not mentioned, but without that relation, right, we will not be able to proceed, because the only relation we have is the total heat that is rejected to the surrounding will be equal to what? Q2 plus W, the heat that is taken from the reservoir, low temperature reservoir, plus the work done. The total value will be equal to what? Q1. So this is the relation we'll have. But unless we relate it to the temperatures, right, we will not be able to find what is the W. So look at this, what we'll have. So from here, right, W will be equal to Q1 minus Q2. W will be equal to Q1 minus Q2. Now what we'll do is we will just take the ratio of W by Q2. So W by Q2 will be equal to what? It will be equal to W is Q1 minus Q2 divided by Q2. That is what? If you split the numerator, means Q1 by Q2 minus 1. What is Q1 by Q2? Q2 by Q1 is T2 by T1, right? So Q1 by Q2 will be T1 by T2, but we should take them in the Kelvin scale. So look at it. T2 value on Celsius is what? 4. Means we have to add plus 273, which will be what? 277 Kelvin, that is T2. Here T1 will be what? Celsius scale 30, means we have to add 273, so it will be 303 Kelvin. So Q1 by Q2 is what? T1 by T2 means 303 by 277. So look at it, 303 divided by 277 minus 1. Take an LCM. What we'll have? 303 minus 277 by 277. So 303 minus 277 will be 26. So what we have is 26 divided by 277. That is our W by Q2. That is it, right? So Q2 is known to us. What is it? In terms of joules, it is what? 600 into 4.2 joules. So we'll just have to take the Q2 to the other side. So what we'll have? We'll get the final answer as what? W will be equal to Q2 into. So from here, what we'll have is W will be equal to what? Q2 into 26 by 277, which is 600 into 4.2 joules into 26 by 277. Okay, so if you simplify this, we will get this close to 236.5 joules. So this is the electrical work to be done in 1 second. Means what? The electrical power will be 236.5 watt. So the correct answer for this is option A. So here what we are doing is we are basically relating the parameters of operating the refrigerator. So for any refrigerator, whether it is ideal or non-ideal, the Q1 value will be equal to what? Q2 plus W. That will be there for every refrigerator. But here if you look at the ideal refrigerator, that will work just like the reverse of the ideal heat engine. Then what is the relation we'll have? The Q2 by Q1 ratio, right, will be equal to the ratio of the corresponding temperatures, which is equal to T2 by T1. So that is how we are able to proceed and get the answer for this question. So here just for the academic importance, we'll also look at one of the important parameters of operating the refrigerator, that is the coefficient of performance. For every refrigerator, right, we'll talk about COP or coefficient of performance, which is generally indicated by the symbols either alpha or beta. So coefficient of performance will be what is the heat derived from the low temperature region or the reservoir, because that is how we'll measure the output, because we are interested in deriving more amount of heat from the reservoir. So if you look at it, right, so what is the interesting point about the refrigerator? We are interested in deriving this Q2 from the low temperature. Okay, and Q1 will be the heat that is given to the high temperature. So Q2 divided by W. So the amount of the heat that is derived from the low temperature reservoir per unit work done by the refrigerator engine, right, that is what we will measure as the coefficient of performance. So look at it, coefficient of performance, right, Q2 divided by W can be written as what? W can be written as what? Q1 minus Q2. So we can write as what? Q1 minus Q2. Now if you divide both the numerator and denominator with say Q2, what we'll have is numerator will be what? Q2 by Q2. Here it is what? Q1 by Q2 minus Q2 by Q2. So that is numerator is 1 divided by Q1 by Q2 means what? T1 by T2 minus 1. So take an LCM, it will be what? T1 minus T2. So the T2 will go to the numerator. So what is it? The COP value, right, will be equal to T2 by T1 minus T2. So this is the coefficient of performance for the ideal refrigerator. So this is an important relation. Otherwise, generally, what is it? The definition of the coefficient of performance is Q2 by W. So in some questions, right, will be also required to use this particular relation. Coefficient of performance or COP will be equal to what? T2 by T1 minus T2. So here T2 is what? The low temperature reservoir, and T1 is what? The high temperature surroundings. Okay. So we'll go to the next question. This is a question that has come in 2015. It's a theoretical question. An ideal gas is compressed to half its initial volume by means of several processes. Means, if you're starting from volume V, we are compressing it to half the volume. Means we are making the final volume as what? V by 2 by using different process. Which of the process will result in maximum work done on the gas? So here when we talk about the different scenarios, right, we are looking at the comparison of the work done. So we will try to represent these on the PV diagram. So let's say this is the initial volume. Okay, so this is the initial volume where we are starting. Okay, and we can choose different processes. If you talk about an isobaric process, means what? Pressure will be constant. So this is how it is till you come to the final volume. So this is half of the original volume. Okay, so this is how we will have the isobaric process. Then an isothermal process as well as the adiabatic process, both of them will be curved, but an adiabatic will be more steeply curved in comparison to isothermal, which means what? If you say, for example, mark this as the isothermal, then adiabatic will be more steeper. More steeper would mean what? So we'll have a curve like this, it will be even more steeper. Okay, so that is how the adiabatic is going to be. An isochoric doesn't make much sense here. Why? Because we are saying, you know, the volume is reduced to half the initial volume, and isochoric doesn't make sense. Why? Because we're talking about changing of the volume, right? So that is never going to be an isochoric process. So we'll just leave it out. So let us compare between these three processes. This is what, let's call them as what? 1, 2 and 3. So our task is to find out in which case maximum work is done on the gas. So if you look at the PV diagram of any particular process, the area under the PV curve will be what? It will be giving us what is the work done. Okay, so here if you look at it, right, which of them will have a higher work done? We can see clearly that, okay, so the work done will be given by area under this horizontal line in case of the isobaric. If you go to isothermal case, means what? We are going to get some extra work done. So you'll see, in addition to that, there is also some area here, isn't it? We'll get some more work done. But if you go to the adiabatic, we are going to get even more amount of work done. Why? Because in addition to this, you are also having some more area over here. So which means what? The area is maximum. You can see here also, if you look at adiabatic, right? So below the adiabatic is where we will have the, so everything will come. So that is the total area under the adiabatic curve. So adiabatic curve is going to give us maximum area below the curve, which means what? The work done on that gas will be maximum, in which case work done on the gas. So here the volume is decreasing, so work is done on the gas. Volume of the gas increasing means what? Work will be done by the gas. Okay, so work done on the gas is maximum when? It will be maximum in adiabatic. Okay, in fact this model of question, right, has already come in one of the other years also. So the correct answer for this is what? Adiabatic process will have maximum work done on the gas. Next, one more question on refrigerator. This is also having this coefficient of performance. The coefficient of performance of a refrigerator is 5. Means, you know, this is the COP value. Either we will indicate this with symbol alpha or beta. Okay. If the temperature inside the freezer, means this is the low temperature. What is it? -20. The temperature of the surrounding to which it rejects heat. So here straight away we are looking at the relation between the COP and the temperatures. So here the assumption is what? We are talking about the ideal refrigerator. Already we have derived the result in the case of a previous question, right? So what is it? The coefficient of performance in case of the ideal refrigerator will be equal to what? T2 by T1 minus T2. So this is the COP value. So here T2 represents what? T2 is the temperature of that cold reservoir, and T1 is what? The temperature of the hot surroundings. Okay, so both must be on the Kelvin scale. So here if you look at it, right, they are giving us what? Alpha they are giving us. This is the coefficient of performance, that is 5. T2 low temperature they are giving -20. We have to convert this into Kelvin, means what? Plus 273 we have to add, so it will be 253. So from here we have to find what is the T1 value. So look at it. So what is the formula we have? Alpha is equal to T2 by T1 minus T2. Straight, I mean this is more like a mathematical simplification. We got it. So alpha is equal to 5, which is numerator is T2, 253, divided by denominator what is there? T1 minus 253. Okay, so now we'll do what? We can do the cross multiplication. So here we will bring this T1 minus 253 to the left side. It will go to the numerator. So 5 we have to multiply. So 5 into T1 minus 5 into 253, that is equal to what? 253. Okay, so now we can rearrange again. We'll take it to the right side. It will become what? Plus. So left hand side we'll have 5T1. 5T1 is equal to what? 253 plus 5 into 253, which is 6 into 253. Okay, now we are looking for T1, means what? The 5 will go to the other side, go to the denominator. Okay, so it will be what? 6 by 5 into 253. If you simplify, means we will get it as what? 303.6 in the Kelvin scale. But we are looking on Celsius scale, right? Look at the options. All the options are in Celsius scale. Means we have to do what? Minus 273. Then we will get what? We will be getting 30.6 Celsius. So we can take it approximately as what? 31. So correct answer for this is option C. So you can probably understand why we are getting not the exact answer but a close by answer. Why? Because we have not taken the temperature conversion as 273.15. Because what is the exact temperature conversion? The Celsius scale value plus 273.15 will be the Kelvin temperature. But we took only 273. So that's the reason why we have some slight difference in the answer, and we are going for what is the most approximate answer to the one that we got. Okay, so these kind of things also we have to be ready to judge, because we get 30.6 and we should not be thinking that okay, we didn't get the exact answer. So we have to think that okay, we have made an approximation in the conversion. So that is why we could be getting some slightly different answer. We'll move on to the next question. This is a question based on the PV diagram. 1 mole of an ideal diatomic gas undergoes a transition from A to B. So from A it is going towards B, as shown in the figure. The change in the internal energy of the gas during the transition. So if you look at it, right, any process, what is the delta U value? NCV delta T, correct? Now delta T means what? Initially we are at point A. Let's say temperature is what? TA. Finally we are at point B. Temperature is what? Let us say TB. So here the temperature values are not given. Observe carefully what is given. At point A we know the volume, we know the pressure. Point B also we know the volume, we know the pressure, but we don't know the temperature. Question statement, they are saying 1 mole of the ideal diatomic gas, means what? We will be able to relate the temperatures to the pressure and volume, right? Because from the ideal gas equation, PV is equal to nRT. What do we have? Temperature will be equal to what? PV by N into R. N is of course 1. Okay, so that way we will be able to relate the temperatures to the pressure and volume, because both at point A we have the pressure and volume, point B also we have the pressure and volume. Okay, and in this delta U formula, CV is coming for a diatomic gas. What is the CV value? It will be 5 by 2R. For a diatomic gas, CV will be equal to what? 5 by 2R. CV will be 7 by 2R. So these values, right, we should keep on top of our mind so that we will be able to solve the questions easily. Okay, now we'll just have to go and substitute them in the respective formula. So this is what we are looking for. Delta U is equal to what? NCV delta T. Okay, so CV is what? 5 by 2R. So delta T means what? TB minus TA. Okay, so here TB will be equal to what? PB into VB by N into R. Similarly, TA will be equal to what? PA into VA by N into R. Okay, so we are just going to substitute. So the TB will be what? PB VB by NR. TA will be PA VA by NR. Okay, so here if you just look at it, right, so this NR will be cancelled. So from the denominator of both these terms, PB VB by NR and PA VA by NR, we can take out the NR common. Okay, so then what we'll have? NR will be anyway getting cancelled. So what we'll have is 5 by 2 into PB VB minus PA VA. Okay, so here what is the PB value? So what is the PB? It is what? 2 into 10 power 3 pascals, because it is kilopascals. We have to be careful about the units, because having done all the thing right, we might just go wrong in the respective unit conversions. So here we have to be careful. Pressure is what? Kilopascals, means it is what? PB will be 2 into 10 power 3 pascals. So PB into VB. volume is in the SI unit only. VB is what? 6. So 2 into 10 power 3 into 6. And since we are taking in the SI unit, the answer is going to come in what? Joule. Okay. And PAVA, what is PAVA means? PA is what? 5 into 10 power 3. So 5 into 10 power 3. VA is what? 4. Okay. So if you look at it, what do we have here? This is 2 into 6 is 12. So 12 into 10 power 3 minus 20 into 10 power 3. So 12 minus 20 is what? Minus 8 will come. So minus 8 into 10 power 3. So here we'll see 2 1s are 2 4s are. So 5 4s are what? 20. So there is a minus 20 into 10 power 3 joule, which means what? Minus 20 kilojoules. Minus 20 in 10 power 3 joules means what? It will be minus 20 kilojoules. Okay. So what is the correct answer for this? Option D is the correct answer. We'll move on to the next question. This is another question based on the PV diagram. This is come in the 2015 cancel paper. The figure below shows two paths that may be taken by a gas to go from state A to state C. So from state A to reach state C, we have two possible paths. What are these possible paths? A, B, C is one path. Okay. AC directly is another path. These are the two possible paths. Okay. In the process AB, 400 joules of heat is added to the system. Means delta Q will be what? That much amount of heat is added means delta Q will be 400 positive. Process BC, this part, 100 joules of heat is added to the system. We have to find the heat absorbed by the system in the process AC. Means in this AC path, right, we have to find what is the heat absorbed. Means we have to find the delta Q. So how these two paths are related? Because we are going from the same starting point and reaching at the same ending point, right? In the path ABC also, what is starting point? A is starting point. C is the ending point. In the path AC also, A is starting point, C is the ending point. Which means what? Which means for both these processes, since the initial and the final points are same, the change in the internal energy, delta U, is going to be same. Why? Because delta U will be a state property, right? Final internal energy minus initial internal energy. So that is the relation between the paths ABC and AC. So what is the relation? The delta U change for the path ABC will be equal to what? Delta U for the path AC. Because they both have same starting point and same ending point. Now what we'll do is we will have to calculate what is the delta U for the path ABC and equate it to the delta U for the path AC. So we'll see how we are going to do it. Okay. So first the path ABC is divided into two parts. AB is one part, BC is another part. So what we'll do is let us just start with the path AB. AB is what you see here, it is a vertical line. So in the PV diagram, vertical line means what? It is an isochoric process. Isochoric process means W will be equal to 0. Isochoric means W is equal to 0. So what is the first law of thermodynamics? Del Q minus W is equal to delta U. So W0 means what? Del Q is equal to delta U, right? So what we'll have is for this path AB, del Q value will be equal to, already del Q they have given. AB, what is the del Q they are saying? 400. Means delta U also will be equal to what? 400. So for the part AB, we got the delta U, that is 400 joules. Let us keep it. Now we'll also try and get for the path BC. Okay, so let us look at the path BC. What is BC? Here is a horizontal line, means what? It is an isobaric process. So BC is an isobaric process, and isobaric process W will be equal to what? P into delta V, correct? W will be equal to P in delta V. So which is what? The pressure is 6 into 10 power 4 SI unit into delta V means what? Final volume, which is 4 into 10 power minus 3 minus the initial volume. What is the initial volume? 2 into 10 power minus 3. So what is it? 4 minus 2 will be 2, right? So we'll have 6 into 10 power 4 into 2 into 10 power minus 3. So totally it will be what? After cancelling, we'll have 110 remaining. 6 2s are 12. So 120 joules. That is our W. So what is the first law of thermodynamics? Del Q minus W is equal to delta U. So del Q is what they are giving in the path BC. 100 joules of heat is added, means del Q is 100. So 100 minus 120. W is what? 120, right? So delta U is going to be what? Minus 20. So what is the delta U value going to be? It will be what? Minus 20. So look at it for this path BC. What is the relation? Delta U will be equal to what? Del Q minus W. That is what? 100 minus 120, which will be equal to minus 20. Okay. Now what do we have? We have for the AB part, delta U is 400. For the BC part, delta U is what? Minus 20. So overall means delta U for the ABC part means what? Delta U for the AB part plus delta U for the BC part, right? That will be equal to what? 400 minus 20, that will be 380 joules. Because delta U for the AB part means what? Delta U for the AB part means B state internal energy minus A state. Delta U for the BC means what? C state minus B state. So when you add both of them, what is going to happen? We'll get internal energy of the C state minus internal energy of the A state. That is what is the overall internal energy change. Okay. And this will be equal to what? Delta U for the AC part also. This will be equal to delta U for the AC. So look at this AC part. This is the AC part, right? Now for the AC part, we have got the delta U. That is here what? 380 joules. Delta U, we get it. We are supposed to find del Q. That is what we are supposed to find. So again, from the first law of thermodynamics, we will have a relation between delta U, delta Q and W. So our task is to find what is the W. So see, we can look at the area below that AC, the area below the AC path and the x-axis. So what is this area? We can probably divide the area into two parts. We can divide the area into how many parts? Two parts. Okay. So one is a triangle you can see, and other will be the rectangle that we are looking at below. So this is the rectangle and this is the triangle. Okay. So let us look at part 1, part 2. What is the area of the rectangle? So this is what? From 2 in 10 power minus 3 coming to 4 in 10 power minus 3, means this width or whatever we call it as is what? 2 into 10 power minus 3. What about this one? From 0, it is up to 2 into 10 power 4 pascals, means it is 2 into 10 power 4. So the area of this part one, which is like a rectangle, right, will be equal to what? 2 into 10 power 4 into 2 into 10 power minus 3. That is what? It is 10 will remain. 2 2s are 4, so it will be 40 joules. Then let us look at this is part 1. Let us look at the part 2. Part 2 is like a triangle. So here the base of the triangle is same. So what is the area formula? Half into base is what? 2 into 10 power minus 3 into height. What is the height? From 2 it is going up to 6, means the gap is what? 4. So gap is 4 into 10 power 4. Okay. So half into base into height, 4 into 10 power 4. So here what we will get? Same. 10 will remain. 2 2 is cancelled. This is another again 40. So what is the overall area below that AC? It is 40 plus 40, 80. So the work done in this case will be what? 40 joules plus 40 joules, which is 80 joules. Now we have to keep one thing in mind, that whenever the volume is increasing for a process, in that case work will be done by the system. W will be what? Positive. When work is done on the system, that is when the volume will be decreasing. In that case, W will have to be taken as what? Negative. So in this case, volume is increasing, so W will be what? Positive. So how much is the W value? W is 80. Okay. So now we have for the path AC, we have the W. We have the delta U also. What is the delta U? 380. So we just have to use the first law of thermodynamics. What is the first law of thermodynamics? Del Q minus W is equal to delta U. So del Q, heat exchange, minus W is equal to delta U, right? So means what? W we can take to the other side. So del Q is equal to delta U plus W will come. Minus on going to the other side will become plus. So delta U is what? It is 380 plus W is what? 80. So totally what is it? 380 plus 80 means it will be 460 joules. So what is the answer for this? It is what? For the path AC, delta Q is going to be what? 460 joules. The correct answer is option A. So here this is a kind of an I don't want to call it as a really tough question, but it's like an exhaustive question, because we have to deal with the part ABC first, find what is the delta U for the overall ABC path, and that will be the delta U for the AC path. Again we have to use the first law for the AC path. If you see, we have applied the first law in 3 cases, for the path AB, for the path BC, and for the path AC also we apply. So that is why it is going to be taking a little bit more time to solve. Okay, so we'll move on to the next question. This is a question based on the relation of the parameters of the gaseous system when we are going through different processes. A monoatomic gas at a pressure P having a volume V expands isothermally to a volume 2V. Means first we are having the pressure of the gas given and volume. It is expanded isothermally to a volume 2V. Then that's the first step. First step is over. Then adiabatically to a volume 16V. So there are 2 steps. First step is what? Isothermal. First step is what? Isothermal. Second step is what? Once the first step is over, we are starting the second step, adiabatic. Okay, we have to find what is the final pressure of the gas. So here if you look at it, right, 2 things. In case of isothermal process, like we have, if you have isothermal process happening between state 1 and state 2, what is the relation? P1 V1 is equal to P2 V2. So this is what is the relation for the isothermal. If say for example from the state 2 we are starting an adiabatic process, then here P2 V2 power gamma will be equal to what? P3 V3 power gamma. So this is the relation in terms of the adiabatic process. This is the adiabatic and this is the isothermal. So we'll have to just see how we'll be able to proceed, because here they have given some values for the parameters. In each of the processes also they are giving some values for the parameters. Look at it, what is it that they are giving? Initially they have given volume is what? B, and pressure is P. Once we are expanding isothermally, the final volume is what? 2V. So let us say the corresponding pressure is what? P dash. Let us call the corresponding pressure as what? P dash. So look at it. So initial pressure into volume, P into V is equal to what? Final pressure we are calling as P dash. This is the isothermal step. Okay, so P dash into what is the volume? Once we are expanding isothermally, the volume is 2V, right? So from here we can see VV is cancelled, and P dash will be equal to what? P by 2. P dash will be equal to what? P by 2. So at the end of the isothermal, the pressure is P dash, and what is the volume? 2V. Now we are going for the adiabatic. Adiabatic expansion, volume is increased to 16 times V. So let us say the volume, the corresponding pressure is what? P final, because that is what we are trying to find. At the end of the adiabatic, let us say the pressure is what? P final. Now look at it. For the adiabatic expansion, right? Initially, what is the pressure? P dash, because we are starting just after the isothermal. P dash into volume is what? 2V, right? 2V whole power gamma is equal to P final. This is what we are trying to find, into what is the final volume? 16V whole power gamma. Now it is more like a mathematical simplification. P dash is what? P by 2. Gamma is what? It is a monoatomic gas. Monoatomic gas means gamma will be pi by 3. This is the monoatomic gas gamma value. We have seen, in few other problems also, monoatomic, diatomic particularly, we have to be very clear in terms of the gamma values. Okay, gamma, Cp and Cv values. So here power gamma is coming in the power, so 2V whole power 5 by 3. This is what? P final into 16V whole power 5 by 3. Now what we will do is we will try to bring the terms. The 16V whole power 5 by 3 we will bring it to the other side, so that we will have the PF. So PF will be what? P by 2. Numerator we have 2V whole power 5 by 3. Denominator we will have what? We will be having 16V. Okay, so power whole by 3 will be common for both 2V as well as 16V. So look at it. This is what? V is anyway cancelled. 2 1s are 2 8s are. So P final will be what? P by 2 into 1 by 8 whole power 5 by 3. 1 by 8 can be written as what? 2 cube. 1 by 8 can be written as what? 2 cube. Now look at it. If you have 2 cube whole power 5 by 3 means what? Whole power 5 by 3 means 3 we can cancel. The remaining inside this power term, what will be the remaining? It will be 1 by 2 power 5. What will be the remaining term? 1 by 2 power 5. Okay, so what is it? P final is equal to what? P by 2 into 1 by 2 power 5. 2 power 5 is what? 32, right? So already there is a 2 in the denominator. So 2 into 32 is what? 64. So what we will get? P final will be equal to what? P by 64. It's a straight. So once we are able to put down this adiabatic relation, we will just have to go on with the mathematical simplification. Okay, so we have to be careful about the dealing of the powers. So how do we simplify when we have powers? Okay, so here the way they have chosen the values are such that we are able to perfectly get the rounded off number. In some cases what happens is the powers might not get nullified, so the answers will be having some powers in those cases. Okay, we'll move on to the next question. This is a question that has come in the 2014. A thermodynamic system undergoes cyclic process. What do you mean by cyclic process? It will have the same starting point and same ending point. What is cyclic process? A, B, C, D and A. This is a cyclic process as shown in the figure. The work done by the system in that cycle is. So we have to find what is the work done by the system in the cyclic process. So here first let us talk about generally. So cyclic process. Think about a cyclic process. Let there be a cyclic process like this. Okay, I'll use a different color to represent. So let us say I'm talking about a very general cyclic process. It is going from A to B and then coming back from B to C. So you know what do you call the cyclic process? We will call the cyclic process an anti-clockwise. The orientation is what it is, anti-clockwise. Okay, so here if you want to find what is the work done in the cyclic process, so generally you know we could have just said what is the result and then solve the question, but we'll just try and see what will be the work done in case of a cyclic process. So here we will divide the cyclic process into two parts. AB is one part, BA is the other part. AB is one part, BA is the other part. Okay, now in AB what is happening? Compression, volume is decreasing. So work will be what? In AB the work will be what? Negative. In BA it is what? Expansion. In BA work will be what? Positive. Now let us represent the area below the BA part. What is it? We will have to represent the area below the BA curve. So this is the pressure versus volume. Okay, now what about the work in the part AB? We will have to represent what is the area which is below the AB curve. We have to represent the area below the AB curve. So look at it. How do we represent the area below the AB curve? This is the AB curve, right? So we will have to represent the entire area below the AB curve. Okay, so this also will come, totally it will come. Now the work in AB part is what? Negative. Work in BA part is positive. So this region, right, we will see what? These two are going to cancel. One is positive, other is negative. These two are going to cancel. The remaining is what? The area which is inside that cyclic path. So we will say work done in a cyclic path or cyclic process, right, will be equal to what? Area enclosed by the cycle. Means the cycle will enclose an area, right? That is what is the remaining work going to be. So here, since it is anti-clockwise, the negative work is going to be higher because the upper curve will be what? Upper curve will be like a compression. So in this case, the overall W will be taken as what? Negative. Area will measure and work will be taken as what? Negative. But instead, we have a clockwise. Let's look at this clockwise process, A to B and then B to A. So in clockwise what happens is the upper curve is what? Observe this, upper curve is what? Expansion. Means the overall work will be what? In that case positive. So this is the convention we have to follow. So in any cyclic process, work done is given by what? Area enclosed by the curve. And in case of the clockwise, as we can see, this is what the one that I have just drawn now. What is it? Clockwise. So in case of clockwise means what? Work will be positive. The upper curve part is what? Expansion. So the system will actually do the work. Work will be positive. But in case of the anti-clockwise, work will be what? Negative, which means work is done on the gas. Okay. So now we'll keep these ideas and we'll go and solve this question. So we just spend some time to revise the theory related to that, so that we will be clear on how this cyclic process problems can be solved. So this is an important one, because we'll see in a couple of other past year questions also the cyclic process related problems have been asked. Okay, so now we'll just go to the question. What is it? It's a cyclic process. What is it? AB CDA. So if you look at it, right, we can see that no, this is like one cycle. Let's call it a cycle 1, and this is also like another cycle 2. So the overall work done in that entire cyclic process can be given by what? Work done in the part 1 plus work done in the part 2. Overall work done will be what? Work done in the part 1 plus work done in the part 2. Now let us look at just the part 2, which is the triangle. What is the base here? From V0 to 2V0 means base is V0. What is the height? From P0 to 2P0 means height is P0. So area here will be equal to what? Half into base into height. Okay. But here what we need to keep in mind is the orientation. So what is it? It's a clockwise. So clockwise means what? W will be positive. So W, this is 2. So W2 will be equal to half into V0 into P0. Why is it taken as positive? Because this is a clockwise. Now let us go to that other triangle, the triangle 1. So we can see here, this triangle also, what is the base? B0. What is the height here? What is the height? 3P0 and 2P0. What is the difference between them? It is P0. So technically area will be same. What is it? Area will be same. What is it? Half into V0 into P0. But observe this. What is this? It's a clockwise process. Clockwise means what? W will be clockwise, or it's an anti-clockwise. Sorry. So anti-clockwise means what? W1 will be what? It will be negative. So we have to take it as what? Minus half V0 into P0. In case of the part 2, what is it? It's a clockwise. In case of part 1, so this is part 2 and part 1. So part 1, what is it? It is anti-clockwise. Area will be same in both the cases, but as per the sign convention, what we will get in the part 2, W is positive. Part 1, W is what? Negative. So when you look at what is the overall work means what? W1 plus W2, right? That will be equal to what? Half into V0 into P0 minus half into V0 into P0. What do we get? We'll get it as what? 0. Now in this case we are getting the cyclic process work done is what? 0. But not in every case, because if you have just one single cyclic process, like one single cycle is there, then what will happen? We'll have a work value, and that will be equal to what? Area enclosed by that cyclic process. And depending upon whether it is an clockwise or anti-clockwise. Clockwise means what? So we have to be very clear with this. What is it? Clockwise. Clockwise means what? Work is going to be positive. Okay, because in a clockwise, the upper part will be what? Expansion. This is the clockwise, right? So clockwise means what? Upper part will be expansion. That is why overall work will be positive. In anti-clockwise, anti-clockwise means what? Okay, so in anti-clockwise, what happens? The upper part will be compression. Anti-clockwise, the upper part will be what? Compression. That's the reason why work will be negative there. Overall work will be what? Negative. But in both the cases, work is given by area enclosed by that cycle. We'll move on to the next question. A gas is taken through the cycle A, B, C, A means starting from A, we are going to B, coming to C, and then back A. This is a cyclic process. What is the net work done by the gas? So here, observe, it's a straight question on what we have discussed. See, what is this? It's a clockwise. And work done is given by what? Work done is given by the area enclosed by the cyclic curve, and since it is clockwise, right? Clockwise means what? We said the work is going to be positive. So we'll just have to apply. So net work done is given by what? Area of that cycle ABC. What is it? This is a triangle, right? So what will be the triangle area? So we have to look at what is the base. What is the base of the triangle? So volume is having unit of multiplier is what? 10 power minus 3 meter cube. Okay. So from 2, the base is extending up to 7. What about the height? From 2, it is going all the way up to 6. We have to see what is the multiplier for the pressure. It is what? 10 power 5 pascals. Okay. So what is the formula for the area of the triangle? Half into base. What is the base? 7 minus 2 into 10 power minus 3. We have to keep the multiplier. Height is what? 6 minus 2 into 10 power 5. We have to keep the multiplier. Okay. So this is what? 5, and this is what? 4. So you'll see here 2 1s are 2 2s are. So how much it is going to be? It is going to be what? We'll just have to cancel the steps, and then we'll have what? This is 2 1s are 2 2s are, 5 2s are what? 10. So already we'll have what? 10 into, there is a 10 square. That will be what? Totally 10 into 10 square means what? 10 power 3 or 1000 joules. So what is the answer for this? Option D is the answer. So it's just that we have to look at the concept behind work in case of cyclic process. Already we discussed in detail in the previous question itself. I said, we have got the cyclic process models repeatedly in the NEET examination. So what is it? The idea we have to be clear. Area enclosed by the curve will give us the work, but clockwise means work will be positive, anti-clockwise means work will be negative, and we have to be careful about this clockwise anti-clockwise, because like it happens in most of the thermodynamics problems, if you see a plus value of the answer, you will also have minus in most of the cases. Luckily here it is not happening. Okay, so this is about the question that has come in the 2013 paper. So this will complete the part 2 of our discussion, and we will see in the part 3.